Good morning, student. Today we discuss about module 5, that is geosynthetics. The geosynthetics are these are the artificial fabrics used in conjunction with soil or rock as an integral part of man-made projects. So whenever because soil is elastoplastic material which is having a small shear strength and modulus of elasticity. If you want to increase your modulus of elasticity of soil, then you can increase by placing these fabrics or geosynthetics into the soil so that the bonding strength will be increased. So then what is the main aim or objective of this geosynthetics is? It is to increase the shear strength, reduction in pore pressure, reduction in seepage, control of settlements, increasing drainage. So these are the many functions which will come afterwards. We discuss about that. What is the main principle behind this reinforcement or geosynthetics? Usually reinforcement is having the highest elastic modulus, that is a high modulus of elasticity compared to soil, and these reinforcement helps when you insert into the soil. What happens? Whatever stress strain acting on the soil, it is transferred to the reinforcement, and this reinforcement is capable of taking higher tensile stresses and increase the bonding between the reinforcement and soil. The major groups in geosynthetics are two, that is geotextiles and geomembranes. Geotextiles are nothing but they are a permeable fabrics. Permeable means they permits the passage of liquid or fluids. Next, geomembranes. Geomembranes are nothing but they are impermeable members, so which is not allowing any transmission of fluids, right? Next, in that geosynthetic types are there. Geosynthetic types are ovens, non-ovens, knitted, biodegradable, nets and grids, and composites, etc. So these are the types of geosynthetics. First we discuss about ovens. Usually ovens were the first to be developed from synthetic fibers. These are developed from synthetic fibers. This type of ovens, about 25% of geotextiles, 25% of these geotextiles market in terms of value. They are manufactured adapting techniques similar to weave and clothing textiles. Weave and clothing textiles. The thread running along the length. Is known as warp. This is along the length. This is known as warp, and one perpendicular called a weft. So this length to this one is running, that's called as weft. So these are highly permeability are obtained with monofilaments. Monofilaments means a single filament. This is thread. These are the threads. When they run in length, then they are called warp. Perpendicular to this length, they are called wefts. So this is nothing but weaving techniques, right? Cross will be done with the weaving techniques. Second one, they are non-woven geotextiles. Non-woven geosynthetics can be manufactured from either staple fiber or continuous filament threads. The fabrics can be bonded together by adopting thermal, chemical or mechanical techniques. Means you can heat. Thermal means you can heat. Chemical means with the help of chemical you can join, or mechanical means you can bind. So with the help of that you can combination, these fabrics can be joined. Next, these non-wovens have a typical thickness in the range of 2 to 5 mm and also tend to be comparatively heavy because large quantity of polymer filaments is needed in order to provide a sufficient number of engaged filaments a crossover for adequate bonding. So non-wovens are not lead resisting geosynthetics. The tensile strength is limited. So because it is having lesser tensile strength, so they can be limitedly used. Next is called as next method that is knitted geotextiles. So knitted geosynthetics are manufactured using another process which is adapted from the clothing textile industry. Normally that is knitting. Normally it is knitting. In this process, interlocking a series of lots of thread. So this is nothing but, so one is interlocked between another thread. So like this one are interlocked. So in this process, the interlocking of threads, interlocking of series of lots of thread or yarn, they are also called yarn, together is made. All of the knitted geosynthetics are formed by using the knitting technique in construction with some other methods of geosynthetics manufactured such as weaving. So here also weaving. What is the advantage of knitted means? Knitted geosynthetics are very much interlocked. Due to the interlocking, they have higher strength, so they can use, maybe can be used for reinforcement also, right? Next, compared to oven and non-oven. So oven geotextiles also very much weave technique, but they can also used as reinforcement or membranes. Okay. Then knitted means they have very much interlocked. So threads are very much threads are very much interlocked. So they have higher strength interlocking. Due to interlocking, higher strength. Next, biodegradable. The main intention of every geosynthetics application is in the long life apart from function. We are not looking for function, but this is long life function. It is intended to play. Usually we are looking for high durability purpose. But these biodegradable geosynthetics are deliberately manufactured to have a relative short life. We are not looking for long span, we are looking for short life. So this is generally used for prevention of soil erosion. Prevention of soil erosion purpose until vegetation can be become properly established on the ground surface. So usually if you take example of a railway track, so usually it is slopy ground. What happens? The surrounding side of the surface is consist of soil. When it is subjected to rain, there is chance of erosion. So that's why if you provide these biodegradable means which are right. Usually grass you can take, jute, nets you can take, those can be provided on that surface. They give the interlocking between the soil and reinforced soil and this jute. So definitely they develop, then there is no erosion of the surface takes place. So usually natural fabrics which can be in the form of paper strips, you can use jutes, nets, wood wool, or you can use coir fibers being used. So these provides acts as a reinforcement, but they are biodegradable, so which can be not a permanent solution, but up to the grass growing. If the grass grows, then there is the interlock between that roots and soil, so no erosion. So up to that we have to provide these type of coils and jutes so that the erosion should not take place. Okay, next called as net and grids. So geosynthetics nets consist of two sets of roughly rounded polymer strands that cross at a very constant angle to give open material with large diamond or rectangular shape. This is nothing but it is a rectangular shaped of apertures net with apertures up to usually 75 mm. So you have the 75 mm can be made. A typical strands means threads or apertures is 2 mm and 7 mm respectively. Usually strands are partially melted. Partially melted means mechanical. With the mechanical method you can melt it, or you can with the help of heat you can melt it, and rolled. So they are rolled here, rolled to produce thermal bonds where the cross. So wherever there is a cross like this is one, this is, so there is a cross here. So here you can melt, right? The strength of nets varies from 2 to 10 kilonewton per meter. So this is very good strength. This form of geosynthetics is mainly used for low strength soil reinforcement or for coir material in fin rain geosynthetic composites. So you can use for low strength. Okay. So next method, last one is this is composites. Last one. Composites means above 5 you can mix two reinforcement, two geosynthetics. For example, if you mix one O1 and another non-O1 geosynthetics and made with combined with each other, then they can give multiple functions. So usually non-O1s are less strength, O1s are very good strength. So if you mix it, one acts as impermeable, one acts as a strong reinforcement, means combination strength will be developed. So composite means one or two material is joined so that the application can be increased. So in next part we will be discussing next class. Thank you.